Hi, welcome to Geospatial Lightning Talks series round 1, Earth Engine Apps. My name is Tomomi, Program Manager on Google Earth Outreach team. We start a series of monthly Lightning Talks by and for nonprofit and scientists and other change makers who want to leverage Google mapping tools and technology for positive impact in the world. We hope those talks will inspire you to think of new ways you can have impact with Google tools and or provide operational or practical hints to improve and optimize your workflow. All right, please join me to welcome this month's speakers. Yay! Thank you for joining. Yeah, I'm so excited to have you here today. All right, so before we start, I would like to call your attention to two things. First is QA feature. You can write your questions in the QA section below this screen, below this page. If you have specific questions to any speaker, please identify which speaker. And the second is a slide link. On the below of this page, you can find a resource link where you can find the speaker's slide. All right, so let's jump into the first speaker. The first speaker is Valerie. She is a spatial ecologist at the Nature Conservancy. She is currently working on a project in the Caribbean, focusing on climate adaptation and mitigation, including coral restoration that she will share with us in a second. Enjoy her talk.
All right, hi everyone, I'm Valerie McNulty, and I'm going to share today how we are using Google Earth Engine apps in the Caribbean to improve survival rates of coral outplants. A common challenge in coral restoration is identification of outplanting sites. In the past, sites have been selected largely based on local knowledge or logistical criteria, but we were interested in finding a way to more scientifically select sites to improve coral survival rates. To address this challenge, we at the Nature Conservancy partnered with Arizona State University's Global Airborne Observatory to fly over and collect multispectral data in two areas, the Southeast Dominican Republic and St. Croix in the U.S. Virgin Islands. The GAO collects 427 samples of light per pixel, which allows us to derive things like live coral cover and habitat complexity, which we cannot do from satellite imagery. Working with our coral manager and partners in the Dominican Republic, we were able to identify optimal ranges for these environmental criteria for specific species of coral. We then used those ranges, such as 3 to 7 meters, to identify areas near Bávaro in the Dominican Republic to target for coral restoration. After divers on the ground verified these conditions, 1,700 Acropora cervicornis fragments were outplanted during a Coral Mania event in 2019. After 11 months, we found that 76% of those outplants had survived, which is higher than the average rate of 66%. Though this is just one pilot project, we think this is a great indication that this methodology can help improve coral survival rates. Finally, we developed the Coral Outplanting Siting Guide, a Google Earth Engine app to put our data and this methodology into the hands of other coral managers and decision makers in the region. We wanted a way for these stakeholders to be able to access our data easily and interact with it without requiring extensive computing power, technical capacity, or software licensing. The app allows coral managers to inspect the data sets and similarly filter the map by specific value ranges to identify new sites for outplanting. Managers can also input the latitude and longitude of an existing site that has been successful, and the app will give them the values of the different layers at that location. This can help managers identify optimal ranges for them selecting future sites. Our partners in the Dominican Republic have already used this app to select outplanting sites for their work, so we're really excited to see those results. If you'd like to learn more or try out this app yourself, you can visit caribbeanmarinemaps.tnc.org.
Thank you, Valerie. Yeah,
Sure.
what an amazing project.
Thank
and
you.
already, positive impact. Congratulations.
Thank you.
Yeah, I think, maybe audience might want to, scale this initiative to other countries. But what is the important thing or necessary things to scale to other countries of your project?
Yeah, I would say that partnerships on the ground are most critical. It can be kind of expensive to get the airplane to a specific location. So if multiple organizations want to kind of split the cost and ensure that users will use the data, that's one way that it can happen. And also if multiple countries or governments work together, it's cheaper for a larger amount of space to be mapped.
Totally. And then, splitting the responsibility, maybe each folks will think about or consider this project more seriously, maybe can bring more impact. Yeah.
For sure, yeah.
Great. Thank you, Valerie.
Thank you.
See you later. Okay. Next speaker is Denis. Denis is a remote sensing statistics interdisciplinary scientist. As a senior analyst at the federal department, his background and interest converge to formulate solutions to real-world challenge in global agriculture monitoring. Let's learn about his app that USDA analysts are actually using for their daily work.
Thank you. I'm Denis from USDA International Production Assessment Division, IPAD, and I'm going to share with you about a GEE application that we have developed to facilitate global agriculture monitoring. IPAD mission is to use remote sensing to produce the most objective and accurate assessment of global agricultural production and the conditions affecting global food security. IPAD informs 3 USDA monthly reports on estimates and forecasts of production and on supply and demand. To accomplish this mission, IPAD analysts are assigned to different regions around the world. And as you can see, the challenge we have is that the sheer size assigned to these analysts is overwhelming, and there is absolute need for high performance geospatial processing capabilities. To accomplish this mission, with that challenge in mind, a GEE application was developed to empower USDA crop analysts to leverage and interface with GEE in a user-friendly and coding-free environment. This has significantly reduced imagery access and processing time in an easy side-by-side geospatial analysis framework. The application was developed by default to have 2 map views, which are supported by panels for inputs and data querying. These map views can be linked and unlinked and can be converted into a 1 map view mode. Over the years, at IPAD, several band combinations and indices have been used routinely and have become institutionalized for crop monitoring. Vegetation analysis is the most used band combination, and NDVI is the most used vegetation index. These are readily available in the application for the IPAD analysts. The application is mostly used for crop change detection and monitoring. And in the season, we are interested in knowing when the crop emerges. In the mid-season, we are interested in knowing how the crop is doing relative to other previous average years. And late in the season, we want to know when the crop was harvested. We also use the application routinely to determine the impact of extreme weather events such as floods, droughts, and derechos. In this example here, we use the application to find fields and areas which were damaged by a flood which went through central Greece last year. Thank you.
Thank you, Denis. Great talk. What an impactful. Yeah, I'm so, surprised to see, you and then other USDA analysts are using for your daily work. But I was wondering, were there any difficulties for them to adapt your tools? If yes, and what kind of difficulties were there? And then how did you overcome those difficulties?
So, there were difficulties, but what we do is provide regular trainings to the analysts. So every 2-3 months, we do have a 1-hour training to the analysts. First of all, I should mention that the app is still undergoing development. It's live, but we keep on adding on new capabilities. True. And when we add on new capabilities, then we train the analysts how to adapt and use the application. That also gives us a chance to review previous things the app can accomplish.
Gotcha. Were there anything you tried to include in those trainings, like share case study to inspire them, or just focusing on technical side? Any tips to contact?
So I work in a place where we face, don't need to go out there and look for them. Every month we are having something going on around the world. So we just take those examples. If a flood went through somewhere, we'll talk about that. If we are looking at what's going on in Brazil, we take advantage of that situation. So we use real events happening in real time to train the analysts. Yes. We don't have to be looking at something is going on around the world.
Right. That is great hint. Yeah. I think. Yeah. Oh, okay. Thank you for sharing. See you later. Bye. Okay. Third speaker is Tina. Tina is a Ph.D. candidate in the Department of Earth and Planetary Sciences at Harvard University. In her current work, she uses remote sensing and an atmospheric modeling to understand fires and air quality in India, Indonesia, and then globally. Let's jump in her talk.
Hi, everyone. Today, I'm introducing 2 Earth Engine apps I made to visualize fires and smoke. The purpose of the Earth Engine apps is to synergize visualizations of fires, smoke, and air quality assessments, therefore making them more widely available to both technical and non-technical end users. First, I'll briefly introduce the background for the first app called the FireCam tool. In atmospheric modeling, we use fire emissions inventories to drive the model and quantify the air quality and health impacts from smoke release from fires. The issue here is that there's a couple widely used global inventories, but they can greatly differ both spatially and temporally. Differences arise in the way inventories integrate satellite-based fire activity, fuel load estimates, as well as emissions factors, the 3 components necessary to estimate fire emissions for different chemical species like carbon monoxide and particulate matter. So here I'm showing a screenshot of the FireCam tool. Users can first select the time range, region, and chemical species from the control panel on the left, and then can visualize the emissions on the interactive map, as well as summary time series plots by region. For FireCam, we also pre-computed 5 metrics using Earth Engine that can help end users to understand biases and uncertainties in the inventories. You can access this app from the link below and can learn more about the project from our 2020 paper in the Spatial RSE issue on Earth Engine. In an ongoing project, we're studying smoke from wildfires in the Western US using NOAA's Hazard Mapping System smoke product. The HMS smoke product is manually produced by Analyst using satellite imagery from the geostationary GHOST satellites over North America. This app helps to visualize the smoke product, ancillary fire and air quality information, as well as complementary ghost imagery. Users can then generate animations of the daily evolution of smoke plumes on the fly using the ghost imagery that's already available in the Earth Engine public data catalog. To summarize, currently the FireCam tool is used by the atmospheric science community as a quick way to evaluate inventories for modeling purposes. The Smoke Explorer is used by our team of undergraduate and graduate students in our ongoing research. And I've also used the app as a teaching tool to introduce how satellite imagery can be used to see smoke extent and fires from space. I hope these two examples can give you some inspiration to make your own apps. Thank you for your time.
Thank you, Tina. Yeah, I found your apps both are really, beautiful. I mean, like even for non-tech people, it's really comprehensive. Maybe it's easy to intellect. So
Yeah,
my
question,
my question related to those aspects. So how do you choose which features you implement, and then how do you even choose which color you will use for your apps? Yeah, can you?
Yeah, so for a lot of my apps, I use a basic format of the 3 panels. So on the left, I have the control panel, which is very basic information, like users can choose the time range or the metrics that they want to visualize. And in the center, they have the map that they can drag around and see different regions. And on the right, you have different plots. And I have my go-to colors for palettes and the charts. So I like to use gray, red, and blue, and orange and purple for the plots. And then for the palettes, I just see which one looks good, and then I use that one.
Okay, so from your kind of the sense. Gotcha.
Yeah, and then for each app, I just start with the basic format, and then later on add more and more complexity to it.
Gotcha. Maybe you here to kind of, reflect the feedbacks from the users or your team members.
Yeah, sometimes I hear back from my advisor or collaborators, and then I add more features so they can visualize more layers.
Yeah. So maybe, Ascension Apps, the good thing with that is that, you can, continue to develop it and then with the same URL. So
yeah, exactly. Mm-hmm.
Okay, great. Thank you, Tina.
Yeah,
See you
thank
later.
you.
Okay, next speaker is Adrian. Adrian is a master's student in the Department of Geography at the University of British Columbia. He has always been curious about the ways to harness the geospatial technologies and then spatially explicit modeling techniques for prompting the coexistence of human and biodiversity. Let's hear about his project to save wildlife in Africa using the EE apps.
Water is an essential resource for life. This fact does apply not just to humans, but also wildlife. In dry places in Africa, water availability is limited and highly seasonal. Therefore, it's very important to monitor the availability and quality of water over time. Unfortunately, we were forced to learn the hard way that not doing so could cost lives. In Botswana last year, about 350 African elephants died due to the consumption of water contaminated by toxic cyanobacteria. Being aware of these facts, we wanted to map the distribution of water across the dry landscape of Kavango-Zambezi, an important transnational conservation area covering 175,459 square kilometers. In the course of the study, we realized that the task was quite challenging because the water in the landscape is often found as ephemeral waterholes. Many of these waterholes are very small to be detected in the available maps at the time. Google Earth Engine apps was very helpful in addressing the challenge. A simple app that we developed was composed of the maps from our preliminary analysis combined with widgets like the slider at the center of the interface. This interactive tool allows the users to identify the best threshold of a spectral index called the Normalized Difference Water Index to identify the water holes distribution. We shared this app with experts that know the landscape very well. And after playing around with the tool, they told us that the value of negative 0.27 was best. This small finding is an integral part of our effort in creating an accurate map that unveils the whereabouts of water in the important wildlife conservation area. With such knowledge, we are one step closer to devising continuous water monitoring efforts across the landscape of Kavango, Zambezi. Thanks for listening, and please get in touch using my email address displayed on the screen.
Thank you, Adrian. Yeah, and congratulations already getting positive feedback from the local authority.
Yeah, it's very exciting.
Yeah, but I was wondering, those waterfall might be changing, depending on the seasons or I don't know, even depending on the year. So how do you keep the data freshness on the e-apps?
Yeah, so thanks to the features provided by Google Earth Engine, we can easily do that and set an automated update of the map to display the freshly acquired Sentinel-2 data in our case. For example, today we can already access scenes acquired yesterday by the satellites, which is very amazing. And in the future development, the app can have an extra slider that allows users to select the specific time range they want to see.
Wow. So you don't need to go to Earth Engine app to, code again and again and again.
No, yeah. It's very convenient and streamlined thanks to Google Earth Engine team.
Great. Okay, thank you. So see you in the end of the session to have a Q&A. Thank you, Adrian. Yeah, before going to next speakers, I would like to remind two things. One is QA. So if you have any questions to speakers, you can write in the QA section below of the page you are looking at. And also we sharing the speaker's slide on the right side of the page. You should be able to see the speaker's slide link. So if you open it, you can find their slide where you can find the links to their apps or the contact info. All right, so next speaker is Rajat. Rajat is a Ph.D. candidate at the Geocomputational System and an IoT Research Group, IIT Bombay, India. His research interests include geospatial application development for forest and an urban environment. Let's hear about his EE apps, Ecoviz, now.
Hello everyone, my name is Rajat and today I'll be talking about Ecoviz. Ecoviz is an Earth Engine app which is used for robust visualization of ecological status and trend for World Heritage Site. And today we'll be talking about the Western Ghats of India. So when we are talking about ecological status, biological diversity plays a very significant role in giving us the signature of how the biological diversity is varying over time. And remote sensing is a very good technology which we can use on the basis of high spatial and temporal resolution Earth observation data archive to get more insights about the conservation sites, how they are faring over time, what is the current status, and something like this. And Google Earth Engine makes it possible with a rich plethora of Earth observation data archive. So the objective is to analyze the proxies of ecological status. The proxies include temperature, precipitation, anthropogenic activities, and some other factors which we'll be seeing ahead. The study area is the Western Ghats cluster of India. So Western Ghats cluster, it spans over a very large area, and it is also one of the hottest hotspots of biological diversity as declared by UNESCO. Now, Ecoviz tries to extract the proxies based on the remote sensing parameters such as changes in temperature, change in precipitation, change in humidity, change in the anthropogenic activities, and then tries to map it to a ecological status and also give the temporal trend with it. So the primary idea is to understand correlation between ecological parameters. Now the current status of Ecoviz, is it is being used by academicians and researchers in their work, primarily conservationists and ecologists, and the impact is associated with real world to provide easy, early to access insights. And in the future directions, it is being planned to enhance it, to add a custom-based geometry, and also to include more study area. So EcoVis works as an app of individual apps, and it tries to analyze various parameters as we are seeing here. And very quickly, we'll shift to our demo. So this is the main screen of EcoVis. You can see all the 37 sites from the Western Ghats cluster. So let us say when I'm clicking on a particular site, you get the options to choose the parameters. Let us say I'm selecting anthropogenic activities. So it is being put that after clicking on read more, you should be able to get more understanding. And this part, the right hand panel shows you the trend surface, and the left hand panel shows you all the results. So as you can see, this is the variation in anthropogenic activities. So feel free to explore the EcoVis interface and get in touch with me if you have any questions or feedback. Or still, if you just want to say hello, please drop me an email. I'll be very happy to reply to it. And thank you so much.
All right. Thank you, Rajat.
Thank you, Tom.
Yeah, it's amazing to see. You can access many like data in your website, right? That is so amazing. So maybe you can accept many kind of users who want to conduct different types of research. Yeah.
Yes.
So my question is, I was wondering, you have already seen any correlations among different parameters in your study area?
Yeah, so that's a very great question because this came to us when we were trying to validate the results. So if we are saying that we are using proxies to see the ecological status or trend, we need to validate it because we are not checking that on ground. We are using the satellite data archive. So we tried with the neighborhood Sanjay Gandhi National Park in Mumbai. So in that national park, we tried to analyze what is the change in land cover and what is the change in vegetation. So there was some correlation, but we are it is not a documented thing yet. So that is a work in progress. So, but yes, this question was there in front of us, and we are working on it.
So we will be looking forward to from you the update. Yeah.
Sure.
And then thank you for joining really early morning for you. Yeah.
Thank
Well,
you so much
please stay with us. Yeah, with the coffee. Thank you, Rajat. Okay. Next speaker is Krishna. Krishna is a Ph.D. student at Stanford University. He combines our understanding of physical processes with data-driven method to forecast natural disasters like tree mortality and wildfires. Let's hear about his recent project about forest dryness mapping.
Hi everyone, I'm Krishna and I'm going to be talking about wildfires today. Not too long ago, the Camp Fire devastated entire communities and lives associated with them in a small city called Paradise in California. Now, this occurred overnight and threw many lives into danger. In order to prevent such destruction occurring in the future, we need to come up with better estimates of wildfire danger. Next slide, please. One of the most important ways in which we can improve wildfire danger forecasts is by improving our estimates of forest dryness themselves. Currently, forest dryness is estimated using meteorological metrics like soil moisture, temperature, or precipitation, but these kind of indirect methods are known to not account for plant-to-plant variability. For example, under the same weather conditions, different plants can have different dryness, thus leading to errors. So in this project, we asked why not use actual measurements of plant dryness and try to improve these estimates. Next slide, please. So we did exactly that. We used microwave radar and optical remote sensing products in a deep learning model to come up with more accurate representation of forest dryness over the entire Western USA. These maps are at 250-meter resolution, and for the first time ever, we have such high-resolution maps for Western US. But I should say that none of this would have been possible if not for the efforts by the staff of United States Forest Service, who painstakingly collected all of this data for our training and validation. Now that we have a working model of forest dryness, which is far more accurate than the current status quo, we created a simple visualizer on Earth Engine apps to help users interactively explore forest dryness patterns in their own local neighborhood. So if we can go to the app, we can see that forest dryness is mapped for the entire Western USA, and you can track these patterns, not just in space, but also in time, as shown on the bottom right, where you can see the historical time series of forest dryness for your point of interest. Can we go to the last slide? So yeah, now that we have a working model for forest dryness, we are currently quantifying how valuable these are for wildfire forecasting. As I said before, since these maps are available for the first time ever, we are in a position to do so now. Parallelly, we are also working with a couple of ecologists from the United States Department of Agriculture to help them recognize any early warning signs of tree mortality. The idea being whenever there's an abrupt decrease in forest dryness, then we might be able to forecast tree mortality. If you're interested in using these forest dryness maps, I ask you to go to the URL tinyurl.com/forest dryness to check out the app and the associated maps. Thank you.
Thank you, Krishna. Yeah, so amazing to see. Also, you could involve U.S. Forest Services and then other, local on-the-ground folks. That is maybe it's quite essential to develop reliable apps. So congratulations.
Well, they are the true heroes. I just sit on my computer, but they actually do the real hard work.
But your role is also essential. Yeah. So my question is, why do you use only Sentinel and Landsat data? Are there any reason not to include other data like a precipitation or elevation to make the map?
Yeah, so why not use all the meteorological indices too? Well, we want to be void of any assumptions baked into the model. So we don't want the model to think that if the atmosphere is dry, then the plants might also be dry. So to get rid of any such assumptions, we only focus on observational data. What we see is what we measure. And that's why we didn't include any of these meteorological indices. Some people think that more the data, the better, but I've been trying to be more careful because more data could also lead to more bias in machine learning models. So that's why we only focus on observational data sets.
Wow. Yeah, that is one, I am that kind of the person. I thought it's better to have more and more data. But wow, it's great to learn for me too. Okay, thank you, Krishna. So yeah, see you later. Okay. The next speaker is Miriam. Miriam is an assistant professor in the Environmental Health Sciences Department at the UCLA Fielding School of Public Health. She is an interdisciplinary environmental scientist with broad interest in examining interactions between environmental change and public health. Let's learn about her app, which is actually used to increase the public health in Indonesia. Unfortunately, she is not with us here, but Tina we have here, is working with her. So if you have any questions to her talk, Miriam's talk, please feel free to write in the Q&A sections. Okay, enjoy the talk.
Hi, my name is Miriam Marlier, and thank you for inviting me here to share results from a recent research project that examines how fires affect public health. Our project is focused in Indonesia, where smoke from fires can contribute to regional air pollution, also known as haze. And in this region, intense fire events are linked to droughts, agriculture, and high fuel load ecosystems known as peatlands. And emissions from these fires include tiny particulates that contribute to air pollution, or PM 2.5, which is harmful to human health. Our team built a tool in Google Earth Engine that uses satellite and atmospheric modeling data to determine where the threat to human health is the greatest. I have here an overview of our Earth Engine app, which we call the Smoke Policy Tool. You can see on the left user inputs, and the tool outputs for health outcomes are on the right. And I'll walk you through details in the next few slides. In the first and second steps, users choose between various years and weather conditions. Then they can select a receptor region from Malaysia, Singapore, or Indonesia to evaluate public health outcomes. Fourth, users can choose various policies, which can target conservation in specific locations or by land management type. Then, based on these selections, the Smoke Policy Tool then calculates changes in PM 2.5 exposure due to fires, the contributions from specific regions, and public health outcomes. Moving to a more applied example, we worked with Indonesia's Peatlands Restoration Agency, known as BRG, to prioritize peatland restoration. Using the Smoke Policy Tool, we evaluated proposed locations and identified areas that would have the maximum public health benefit if fires were to be reduced there. Now, to wrap up, there is a significant public health burden associated with regional haze in Indonesia. The goal of the Smoke Policy Tool is to protect populations from future fire-related air pollution. This can be used to support priority conservation projects that would benefit public health the most. And I have the link to the Smoke Policy Tool here, and I encourage you to take a look yourselves. Thank you.
Thank you, Miriam, for your great and an inspirational talk. Yeah, it's great to see the local VG, the local agency is using your app. Yeah. Okay, and then we have last speaker. Last speaker is Zander. He is a geospatial research scientist at the Norwegian Institute for Nature Research. His recent work has focused on mapping and visualizing urban green infrastructure and then ecosystem services that benefit society. Let's learn the details about his work. Unfortunately, he is not here with us. If you have any questions to him, please contact him directly. His contact can be found in his slide. Okay, enjoy the talk.
I'm Zander from the Norwegian Institute for Nature Research, and I'll share with you 2 use cases of Earth Engine apps in my science. Some of you might be familiar with the concept of green apartheid, which defines a spatial inequality and distribution of green space in urban areas. And because green space provide ecosystem services, this raises concerns about issues of environmental justice. We used Earth Engine, Copernicus, Sentinel satellites, OpenStreetMap, and census data to map this green apartheid over South Africa. We found that, for instance, while white citizens occupy 16% of the population, they have a disproportionate share of the income and urban green space. We also published an interactive web application with Earth Engine apps to advance the impact of this work, where users can zoom into their city and their neighborhood of interest, update the graphs for the data within the area of extent. They can also hide graphs in case they want to take screenshots of the maps. We also added the ability for them to swipe between maps instead of viewing them side by side. And finally, also the ability to hide and show legends so that they can share more screenshots with colleagues. This has really advanced the impact by being adopted in media articles and raised awareness and generated further hypotheses about green space. The second use case is in Oslo municipality, where we're trying to decide where to plant green roofs, which provide a range of ecosystem services, but are also contested by a range of stakeholders as to where to plant them. So we created an interactive web app in Norwegian and English where users can zoom around the city to areas of interest and view the prioritization of roofs for potential green roof fitting. And these are based on a range of ecosystem services that green roofs would provide, including temperature mitigation, private green space provision, street level noise mitigation. Users can also click on individual roofs and get the ecosystem service weightings or scores for that individual roof. These scores are combined into an overall prioritization layer, but the weightings of these ecosystem services can differ between different stakeholder profiles. For example, office or industrial building owners might have different valuation of ecosystem services. So in a stakeholder workshop, we can update the map on the fly to compare how these stakeholder profiles differ. We also add the ability for users to manually input their own scores and explore how this changes the map. This is really advanced stakeholder engagement and democratized municipal planning in our work. Reach out for further discussion. I'm Zander from the Norwegian Institute for Nature Research, and I'll share with you 2 use cases of.
All right. Thank you, all speakers. Yeah, thank you for sharing really great work. I was so amazed with your talk on the apps. Hope you enjoyed other folks' talk as well.
Yeah.
Okay, now let's take a look at the QA. So we have a couple of questions from the audience, so maybe we can cover those questions. Then if we have still time, maybe speakers can ask other speakers. Yeah, sounds okay?
Yep. Yeah, sounds good.
Okay, first questions from Brandon to Valerie. Hi, Valerie. Is the Arizona State data hosted on Google Earth Engine and free to use?
Yes, the data that we collected in the Dominican Republic and St. Croix in the U.S. Virgin Islands is publicly available through our app, which you can find at caribbeanmarinemaps.tnc.org.
All right, great, thank you. And then next question is from Virginia to Denis. Hello, Denis. Can it be applied this for natural disaster analysis?
Can you say that question again?
Yeah, I will repeat. Hello, Denis. Can it be applied this for natural disaster analysis, not only agriculture monitoring, but a natural disaster monitoring?
Yes, because we also actually that's one of the purposes we did develop the application. So as long as an event, an extreme event or disastrous event can be picked up by satellite imagery, yes, you can use that application.
Okay.
As soon as the imagery is available in Google Earth Engine catalog, yeah, you can use the application to do that assessment on that disaster.
So data availability or what kind of data in data catalog is really crucial to develop this kind of apps, right?
Yeah.
All right. So next one is from KNS to Tina. All these tools can be developed in Earth Engine or visualizations, e.g. as it is used in the Fire app.
So the fire inventory data is developed by different groups, and I just formatted all of the data sets in a format that Earth Engine can read. So I uploaded all of those data sets to Earth Engine, and then I created the metrics within Earth Engine using the data sets that are already there in the data catalog. So I combined the data sets together in this app so that users can quickly visualize both the metrics and also the data from the inventories.
Gotcha. Okay. And then I think that's all from the audience. Yeah, we have still time. So if anyone you are watching this video, please free to write in. But since we have still time, maybe we can jump in panelist questions to panelists. That's okay. So maybe to Adrian from Krishna. That is, but maybe, oh, Krishna, do you remember which question you asked? But I'm happy to read it.
Yeah.
Adrian,
I
do you
think I
remember?
can. Krishna asked about what function that is available on Earth Engine that allows us to, use the most updated data without having to go back and forth to the app. So the function is called. It's using the EE simply by typing ee.date, and within the and within the function you pass in the date.now, as simple as that, and the function will return the current date, and then you can use that to advance the time or going backward in time. So yeah, it's pretty straightforward using Earth Engine.
Any comment, Krishna?
That's going to save me a ton of time because currently I believe it or not actually refresh it by myself every 6 months or so. But this is great. Thank you.
Wow.
Glad.
Great. Me neither. I didn't know that, so good to know that. Okay, then next one from we have two questions to Krishna. One is Rajat. Can I read it? Read it up, or Rajat, you can.
Yeah. Okay, I'll ask it. No issues.
Yeah.
So, Krishna, that's amazing work. Like visualizing wildfires I think, is a very common phenomena in the United States. And what I was curious to know about is the labels which you have used for your deep learning model. And the next thing is you mentioned that the spatial resolution is 250 meters of the wildfire maps. So, are there any plans or is there any need to
Oh,
enhance
right.
the resolution in the coming times?
Mm-hmm. Yeah, so the labels, I mean, the training samples, the actual data that we get from someone who goes to the field and collects that data. Yeah, so that's like an extremely crucial part of this. That's why I wanted to stress that part. It's been collected about 250,000 times by the United States Forest Service just by going to the field, plucking a piece of foliage from the canopy and measuring the amount of water in it. And not just that, they also geo tag that location so that it's easy for people like me to work on, but then I assume it's quite cumbersome for them to actually do all of this. So that's extremely great work by them, and it's all available on the public domain for free to use. So it's just called the National Fuel Moisture Database. I'll repeat, National Fuel Moisture Database, and it has all of this data just in lookup tables. That's great. And resolution, yeah, as of now, there's no such plans. Generally, people are working with wildfire risk analysis at orders of kilometer scale data. So at the moment, 250 meters is way more than sufficient. But if, I don't know, if future problems or problem statements come up which necessitate high resolution, then I might take a look at that again.
Okay, thank you. Yeah, it sounds very reasonable.
Okay, good. So we got one question from the audience, but maybe Tina, you can ask the questions to Krishna.
Sure. So I was looking at Krishna's really nice app, and then I was noticing missing values, and also there seems to be jumps in values across what seems to be coinciding with the Landsat tile boundaries. And I was asking if he's planning to incorporate some kind of a smoothing method to get more consistent values spatially.
That's a great suggestion. Also, a very neat observation. You have very good eyes. I should do that. So that's a great suggestion. I should look into smoothing the output. As of now, it's just showing whatever was the last estimate available, and that's why there are these jumps in the forest dryness estimate, but I'll definitely look into that.
Great. Thank you, Tina, for your suggestions. Yeah, I can see Krishna's app will improve dramatically. Yeah, okay. So one questions from the audience, actually two all. So maybe I will ask each of you. So from Harley, as you have been working with different data sets and learning how to make GEE apps, what are some of the most important things you have learned? Any good tips for people just starting to get familiar with Earth Engine? So, yeah, maybe the order of the talk, maybe Valerie, what do you think?
I think for me, developing the app alongside the users was the most helpful piece of advice I could give, because I kind of developed a first version and showed it to them, and they were like, this isn't really what we need. So doing that kind of iteratively helped a lot with the functionality.
Yeah, for sure. Yeah, thank you. How about you, Dennis?
So, being involved in problem solving, every month we have to deal with these problems around the world. So I already knew the kind of data which is available, readily available to us, and freely available. And that's what we use. So it was easy for me to decide what data to use. Basically, it's Lancet, Sentinel-2, and Modis. And now we've incorporated beers in there. So it just came from experience that we had this problem. I was experiencing it when I joined the team. Then I decided to make this data available in a high performance geoprocessing platform like GEE.
Gotcha. Okay, okay. Then how about you, Tina?
I would say first, just familiarize yourself with different widgets in Earth Engine and learn how they work. And you can do this easily by going into the examples that's available, and you can modify the widgets and see how they work. And once you know how they work, you can make a simple app and then just add more and more stuff to it. And I would also suggest to test your apps very frequently and also see the different functionalities, because I often find different bugs in the app.
Yeah, start small and find the bug. Yeah. Okay, so Adrian, how about you?
Yeah, something that fascinates me about working with Google Earth Engine in general and Google Earth Engine app is the support that the Google Earth Engine developers provide to each other. So there are so many resources available online already, and some of the resources are available already now by the generous people who share their apps right now, and you can start there without having to reinvent the wheel, and see how people do things, and just see which one would work for your app or what you're trying to do. And then hopefully you would not feel too intimidated to start.
Yeah, yeah. Just start. Try it. Okay. How about you, Rajat?
Yeah, so I agree to all the points which have been already covered now. So it is very important to think in terms of a user perspective instead of a developer's perspective. So, and one more thing, like which was very clear when we started developing this app from my mentor side, was that we should not let the user go from our app. So the screen should be constant. So, like in the app, when you are trying to start a new parameter, or you're trying to analyze a new parameter, it usually reloads a new screen. So that should not be the case. And this is why we try to incorporate a particular app by combining different individual apps. So this would be something which I learned a lot while developing the app.
Yeah, totally. So
And thanks to
helpful.
Miriam for the question. Yeah.
Okay, last Krishna, how are you?
Oh gosh, I think all of these are great suggestions. I don't have anything to add. Maybe one broad perspective, just like everyone has given very good suggestions. One thing that I've learned is that just more broadly, is that like whatever study we are doing or publishing, academic paper, whatever, that's like all nice and good. But then as soon as you put out something out there which is interactive and users can actually use, visualize, exercise with it, and not just read up something or look at some figures, it just shoots up in engagement and the amount of interactions you get. So it's really neat to, if you want to create an impact like that, then I found that the publishing aspect and the papers just go so far, but then making some kind of an interactive tool, not necessarily Earth Engine apps, I don't know, it's not an advertisement, any kind of interactive tool has helped me a lot to gain that engagement.
Yeah, absolutely, absolutely. And thank you all for sharing really learning for tips. I learn a lot as well. Okay, so that's all the questions. So yeah, thank you again for a great talk, all speakers.
Nice meeting all of you.
And
Thank you so much for
yeah.
having us.
Yeah.